So piecewise functions. I think the main struggle with piecewise functions is I feel like they've presented backwards, because here's the function and here is when you use it. So when you're using these things, you have to look at this part first. You have to look at the x part first. The x part is the if, and this part is the then. So if x is less than -2, then you use this function. If x is between -2 and 2, use this function. If x is greater than 2, use this function. The problem comes when students try to do this part first and then use the if part. Like, no, you only use one of these pieces based on what the x is. So it just, I don't know, it always felt out of order to me. First, you use the if part, and then you use the then part. And that's why I think that's the source of confusion, because it feels like it's backwards. Why didn't they write it the other way? And I feel like it would have made more sense. All right, so back to 1 through 3 here. First, begin by observing the value of x at which you want to find the value of the function. So yes, you're going to use the second part first. Determine which equation within the piecewise function is valid for your x value. Do not plug it in all three and then make a decision. You make the decision and plug it in one spot. Plug your x value into the one equation that it fits in. A lot of times I'll label them A, B, and C just so we can talk about them. And so I can say, if I want to evaluate f of -3, which piece should I plug it into? Piece A, piece B, or piece C? A, because -3 is less than -2. So I'm going to plug it into part A, and I don't care about parts B and C, because when x is -3, those don't apply. 4 minus 5 times 3, 4 minus 15 is -12. I'll break them up like this. See if we can fit them in there. F of 4. Again, don't plug it in anywhere. First, look and figure out, for 4, is that going to be on piece A, piece B, or piece C? C. So then I will plug it into piece C. 4 squared plus 1 is 17. Uh-oh, what'd that mess up? -3. I wonder you guys were whispering and wondering. So 4 plus 15 would be 19. Thank you. Did I get 4 squared plus 1 right? Yes. Back on track. F of -1, which piece is that? A, B, or C? B. -1 between -2 and 2. So how do I plug in -1? You don't. A misleading question there. What's my answer then? 0. F of pi takes a little bit of thought, which C, because pi is 3.14, greater than 2. So I'm just going to leave this as pi squared plus 1. That would be an exact answer, so let's leave it as that, rather than grabbing a calculator and getting some decimal. Do you know what E is, roughly? 0.7-ish. So that's also on part C. So E squared plus 1. E, you just have to, E is like a number from calculus. The definition of it is kind of crazy. But you just need to know that it's 2.7 ... It's kind of like pi. It goes on forever, never repeats. Irrational is the fancy word for it. All right, just to make sure you got the hang of it, why don't you try example number 2 then? All right, graphing piecewise functions. When graphing piecewise functions, only graph the equation where it's supposed to be, right? So it's still this, if x is less than 0, then graph this part. So it's still this backwards thing where you got to graph this, or you got to consider this first, and then only graph this stuff where you're supposed to be. And this is where it's fun because you can color code things. So I'm going to say this is part A, part B, and got the green one, part C. We're gonna build walls at the dividing spots. So, excuse me, those aren't asymptotes, but those are gonna help me differentiate what goes where. So less than 0 is gonna be part A, and then there'll be a wall at 3, at x equals 3. Between 0 and 3, we'll go graph B, and then greater than 3, we'll go graph C. Now, sort of like asymptotes, those aren't part of the graph. Those are just kind of helper lines to keep me clear on what goes where. Okay, so when x is less than 0, I'm going to graph negative 1/2 x squared. Let's see, so parabola, but upside down and squished. So, or you could just plot some points. 0, 0. 0 is on the wall. Open circle or closed circle? Do you remember this? Closed, because A sort of owns the wall. A gets to claim the wall here. If we plug in negative 1, well, that would be a half. The 1/2 on there. 2 squared would be 4, but half of that would be 2. 3 squared is 9. Half of that is 4.5. So there's our squished, flipped parabola, but only where x is less than 0. I just plugged in x's. Now, if you know what the graph looks like, you don't have to plug things in. You can just graph it. But if you're not sure, you just plug in values. Y equals 2, or h of x equals 2. What does that look like on a graph? Straight line at 2, I would say all lines are straight, so be a little more specific. I think I know what you mean. Horizontal line at 2. Although I need to be careful at the walls. At the left wall, what's happening with this open circle? Now, that wall belongs to branch A, so part B better stay off the wall. At the right side, at x equals 3, closed circle, because B kind of owns that wall. He gets to sit on that wall. And then part C, 3x minus 12. So I would, well, if I was graphing it normally, I'd start it down 12 and go up 3 over 1. But a couple of problems with that. This graph doesn't even go down to 12. And I'd be in the wrong neighborhood if I started it down 12. So I think I'm just going to start at 3. Plug in 3. Let's see, 3 times 3 is 9, minus 12 is negative 3. What about the wall situation here? Open circle. And then from there, the slope is 3, so I'll just go up 3 over 1. I'm not going to really plug in points. I know the slope is 3, so up 3 over 1, up 3 over 1, and so on. Now, the wall thing is kind of silly. It is not part of the graph. But if it helps you visualize, who goes where and helps you keep straight what graph goes in which neighborhood, then I have no problem if you want to keep building walls when you're graphing with piecewise. Some people don't even think about it. They just do it. But to me, it helps visualize and see what goes where. Yeah. So the walls go where we change from one function to the other. So like we're changing at 0, so there's a wall at 0. Something's going on at 3, so we put a wall at 3. Any other questions on piecewise graphing? All right, why don't you try number 4? Again, building walls is up to you, but using colors is up to you. So I kind of go overkill on trying to keep everything straight. If you are going to build a wall, where would your wall or walls be? Where would your walls be? Yeah, only at 1. Because less than 1, you're graphing A. At 1, you're graphing B. And then greater than 1, you're graphing C. So if I'm doing this problem, I'm going to build a wall at 1. And then kind of label things ahead of time. Graph A is on the left. Graph B is on the wall. And graph C is on the right of the wall. So I'm going to press pause and let you finish that graph. And then we'll check and see. A combination of parent function knowledge plus just plugging in points, you can come up with a graph. Open circles for graph A and C because they don't equal 1. Obviously, B is a closed circle because it's the point. Kind of cruise through that. Any questions on that? The mistake that people make is they put things in the wrong spot, or they'll have like graphs that are overlapping. It's like, I don't know, they like make the V like that. Like to me, there's an obvious problem if you say that's the graph of a function. What's an obvious problem with that? Vertical line test. That's not a function. So something's not right there. And so, take a step back when you're done and make sure you've only got, 1 graph per neighborhood. All right, writing piecewise functions. So this is sort of thinking backwards and looking at a graph and being able to come up with the equation for what we're looking at. So this is tricky, but don't be intimidated. Start with in fact, you kind of work backwards. Start with what x values should go where. And so you could almost put the walls in there and start thinking backwards here. Again, maybe the walls is overkill and you think that's a dumb idea. But I like to visualize what's going on. Now I've got part A and part B and part C again. So f of x equals, I know I'm going to have 3 parts, A, B, and C. I'm going to put the x stuff on first, right? Like you use the x stuff first. So even though the x stuff is written in the second column, I'm going to write it first. So for part A, that's when x is left of -2, less than -2. Equal sign or not equal sign on that? Equal sign. The closed circle means we want to include -2, at least for part A. So less than or equal to -2 for part A. All right, for part B, again, I'm doing all the x values first. I think some people would do all of part A first, but I want to get the neighborhood set, and then I'll go back and figure out the function. Part B, that's from -2 to 4. So -2 is less than x is less than 4. And then I got to worry about the less than or equal to, or the equal to parts. So at -2, open, well, it is an open circle. What does that mean for equal sign? Yeah, not an equal sign, just less than. Because I don't want to include -2 in section B. But 4, it is equal to, because there's a closed circle there. So I want to include 4 in neighborhood B. jumping to neighborhood C means I don't want to include 4 in neighborhood C. Neighborhood C is just x is greater than 4. Okay, I hadn't even considered what the equations of the functions are yet. I've just got the neighborhood set up right now. But that's how we did when we were graphing. We started with setting up the neighborhoods. So same thing, set up the neighborhoods. Now we can figure out what function this is. It might be helpful if you need to extend graphs to get a better view of them. So, right, this isn't my answer, and this would not be correct if it was my answer. But if it helps to draw that line so that you can basically see where this x-intercept is, excuse me, y-intercept. So that would be, that's just a line, mx plus b, slope of -1, y-intercept of +1. So that graph is -x plus 1. And don't, occasionally I'll see people put y equals -x plus 1. I mean, I know what you mean, but you already have the y equals part there. So just put the -x plus 1. And again, this isn't my answer. This is just to help me get the answer. So you don't need to go back and erase that for this one. You can leave that there if you want. It's fine. On the other hand, if it's messing you up, then erase it. All right, on the other side, it looks like we got, or in graph B, we got a parabola. So let's see. It's upside down. And it's been moved up 3. So we got to use our parent function knowledge here. So -x squared up 3. Yeah, it looks like it's not as steep as it ought to be. Over 1, down 1/2. Over 2, down 2. So there's a 1/2 in there. So -1/2 x squared plus 3. There was no left and right shift, so I didn't have to worry about that. -1/2 x squared plus 3. And then lastly, oh, that's an easy one. Y equals 2, or f of x equals 2. So writing equations while looking at a piecewise graph, it can be intimidating because there's like 6 parts, or maybe 8 or 10 if we really wanted to go crazy, but there's lots of parts to get right. So you don't just jump in and scribble out the answer like it's a quick problem. Like you got to slow down and think about, how do I set up my neighborhoods? And then how do I figure out each equation? And that takes a little thought for all of those pieces. So don't speed through that. That takes a little time to think through. Number 5, write a piecewise equation for this graph. Okay, that's kind of weird. Like, why would I do that? I've got an equation already. I think I want to look at that graph before I try to write an equation for it. So I know absolute value makes a v. What's this +2 do to the graph? Left 2. So there's the picture. So it looks like I'll have 2 functions to describe that. Again, take your time on these. So got 2 neighborhoods, neighborhood A, neighborhood B. Neighborhood A is less than -2. We got a open circle or closed circle? It's kind of a trick question. And let me write B's. This will be better. So it doesn't matter where the equal sign goes because they're at the same spot. So I can either throw it in with A or I can throw it in with B. It doesn't matter. Don't do both because then, well, I guess it would still be a function because the point is the same point. But in general, don't put it on both because they might not get a function. So the equal sign needs to either go with -2, I mean with the less than or with the greater than. It doesn't matter which one. Dia? It didn't tell us what to call it, so I could have called it y or g of x or h of x or. Pardon? This one says g of x. So but I'm gonna rename it. So I picked a different. If you called it g of x again, that would be okay. Well, is it a different function or not? That's kind of a good question because it's going to be defined differently, but the graph is going to be the same. So I would accept either answer on is that the same function or not. Well, the picture's the same, but the equations aren't the same. I think part B is easier, so I'm going to do part B first. Let's see, that's a slope of 1 with a y-intercept of 2, x plus 2. And plug in some points if you're not sure. If I plug in -2, I get 0. Plug in 0, I get 2. Plug in -1, I get 1. So yeah, I feel good about that. Part A, still a line. What's the slope of the line? So -x is the slope, but the y-intercept is -2. Weird question. Turn an absolute value equation into 2 or into a piecewise equation. Questions on that one? A lot of stuff involved in that one. Let's see, average rate of change. It's piecewise, but let's think average rate of change first here. What's average rate of change mean? Slope. Good old algebra 1. So the average rate of change from -3 to 13, f of 13 minus f of -3 over 13 minus -3. All right, so how do I get f of 13? Which branch is that on, A or B, if we want to call them branches here? Be branch B, bigger than 0. Square root of 16 is 4. F of 3, excuse me, f of -3. That's less than 0, so that's coming from branch A. So -3 squared minus 5. That's one where some people would actually get it wrong with a calculator because they don't know parentheses. If I square -3, I get 9. 9 minus 5 is 4. Zero over 16 would just be 0. Average rate of change is 0. Yeah, so it means that's flat, but it's flat because the two y values were the same. So I don't know what's happening between -3 and 13. But the y values were both 4. So whatever was going on in between there, I don't know. Average rate of change just means, like, draw a line between those 2 points. That slope 0, so average rate of change is 0. Even though in between there, who knows what's going on. That's like a parabola. The other side is some weird square root. I don't know. But it doesn't matter. I don't care about those. I'm only looking at this overall average rate of change slope line is only looking at those 2 points. So it was a good reminder for average rate of change. Ooh, a word problem. During a snowstorm, it snows at a rate of 1 inch per hour for the first 2 hours, at a rate of 2 inches per hour for the next 6 hours, and at a rate of 0.5 inch per hour for the final hour. Okay, so already I'm thinking 0 to 2, 2 to 8, 8 to 9. Well, that's nice. The graph goes up to 9, so I'm on the right track here. Write and graph a piecewise defined function that gives the depth of the snow, and we were given the rate of snow, so let's be careful here, during the snowstorm. Call your function S of t. I'm starting down here at the bottom because I'm wondering if I'm going to have to think through some things before I get my final answer. Okay, so from 0 to 2, the rate was 1 inch per hour. From 2 to 8, the rate was 2 inches per hour. And then 8 to 9, the rate was half an inch per hour. So that doesn't define my function, but it at least helps me think about things. Depth of snow during the snowstorm. Well, it doesn't tell me where it starts, so I think I can start at 0. So for the first 2 hours, the rate is 1. What is rate? What is that another word for? Slope. So the slope is 1 for the first 2 hours. So that makes sense. So after 1 hour, I've got 1 inch of snow. After 2 hours, I've got 2 inches of snow. I'm thinking I'm going to graph this before writing the equations, but you could argue that you'd rather graph it or write the equations first. But I don't know. All right, from 2 to 8, I want to sort of switch to my color-coded silliness here. So from 2 to 8 also means I've got, you really want to go overboard with the coloring and the walls. A little overkill here, but that's okay. Trying to keep things straight. So from 2 to 8, my slope is 2. So I'm going to start where I left off, right? I can't be jumping around like height of snow doesn't just automatically jump somewhere. After 2 hours, there's 2 inches of snow. But then my slope is increased to 2. I'm going to go up 2 over 1 until I get to the wall. And I'm not really concerned about open circles and closed circles at the wall because it doesn't matter who claims it. It's going to be the same point. Right, so there's B. And then for that last hour, the slope's only a half. So during that last hour, I'm only going to gain a half an inch of snow. So I'll end at 14 and a half. Okay, again, I'm going to start with the x values. I guess this is t values. So from 0 to 2, I've got one equation. From 2 to 8, I've got another equation. And from 8 to 9, got my last equation. Okay, I need to think about equal signs here. So at 0, do I want to include 0 or not include 0? I think I want to include 0. What about at 2? Who wants to claim it, A, B, or C? Well, I heard A and B, and the fact is it doesn't matter. You could assign it to either one. Because either way, I need to have a point there, so don't leave them both open, but don't make them both closed. So make one of them equal to, and so we'll just claim that it goes with A. Again, it doesn't really matter. And then kind of the same thing with 8. You know, do you want to let B claim 8 so it gets to claim one of the walls, or you want to put, it doesn't matter. We'll let B have a wall. And then for 9, we want to go all the way to 9, so let's include 9. But there are multiple places to put those equal sign. Put them on one, but not on both. Okay, 0 to A, I need an equation. Well, that looks like an easy equation. That's just y equals x. So, well, we don't have x, we got t. So, t. For part B, my slope is 2. But I don't want to just put 2t because if I was at time 2, that would say my height was 4. So I don't. So how do I figure out what else goes on this? I know it's 2t, but where did you get minus 2 from? Okay, a couple ways to do it. Like you said, drag it back. You meant like kind of do that? Continue. Just kind of dot it back to see where the intercept would be. That's definitely okay. That intercept would be minus 2. Another way to do it would be, well, plug in 2 and make sure you get 2 for an answer. 2t minus 2, 4 minus 2 is 2. So yeah, I feel good about that. Sort of just force it to match up. And on that last one, the slope's 1/2. So I either dot it back or I figure out what I need to put on there so that if I plug in 8, I land at 14. So if I plug in 8, half of 8 is 4. I would need to add 10 to get to 14. So that's one way to think of it, is like, well, what do I need to add to make it land at 14? So 10. The other way, it's, I hope this lands at 10. I kind of dot my line back with a slope of 1/2. Yeah, it lands at 10. So if you need to sort of visually see the y-intercept, then you can do it that way. If you want to figure out what makes 8 work, then you can do it that way. Questions on that? Again, just take it slow. Can't rush these things. How many inches of snow accumulated from the storm? 14.5. Easy now, we got the graph. 14.5 inches. Write and graph a piecewise function that gives the rate the snow falls during the storm. Oops, we're off the page here. Write and graph a piecewise defined function that gives the rate. I think this is going to be easier than the first one. Right? In fact, I almost did that up here. That's basically what this first thing is, because this is the rate. So the rate's either 1 or 2 or 0.5. And there's my t values. So I think I need to take this table, sort of rearrange things, and that's going to be my answer to part C. Again, I'm going to do the t's first. So from 0 to 2, it's something. From 2 to 8, it's something. And from 8 to 9, it's something. And again, the equal sign there. Make sure the wall has one equal sign on it, but not two equal signs. So I'll just match it to what we did before. A can have two equal signs. B, I'll throw the equal sign on the 8. C, I'll throw the equal sign on the 9. Lost my color coding for this one. I was so excited that I kind of had already answered this problem. From 0 to 2, the rate was 1. 2 to 8, the rate was 2. And from 8 to 9, the rate was 1/2. Okay, graph that. So constant rate of 1 from 0 to 2. Close circle. 2 to 8, rate is 2. And our rate's 1/2 from 8 to 9. This is a good graph to see that if you had put equal sign on both of those 2's, like if you put an equal sign on both of those 2's, why would that be a problem when it comes to the graph? Wouldn't be a function because you wouldn't pass the vertical line test. So again, you can put it on either one. So that means we could have written it so that this was closed and this was open. Either way is fine. Same thing over here. But this is a good graph to see that we only want one of them closed, because otherwise we don't pass the vertical line test. I feel like C was an easier question than A was. Find the area between the graph of R of t. Okay, that's what we just did. This is R of t. And the t axis. Okay, so like the area under the curve. This doesn't look too bad. It looks like 3 rectangles to add up. So the area is 2 times 1 plus, be careful, don't do 8 times 2 because the width of that is 6. 6 times 2. Plus 1 times 1/2. Thank you. So let's see, that's 2 plus 12 plus 1/2 is 14.5. Does that number sound familiar? That's how much snow fell. Like we already figured that out. We didn't do it that way, but that's how much snow fell. How does this answer compare to part B? It's the same as B. It's how much snow fell. The reason they ask that question is because in calculus, we do that a lot. Find the area under a curve. In calculus, though, curves are going to be like crazy looking, harder to find their area. But we'll worry about that when we get there. All right, so piecewise, just be careful. Draw the walls. Use colors. Go slow. Don't rush anything. And you'll be okay. All right, the worksheet next is number 5. And you've got time to work on it.